Okay, students, let's start with our lecture. Our first topic is introduction of the Java. Java is basically a purely object-oriented programming language. The purely object-oriented language means the Java programs always start with classes and objects. Each program contains at least one class. Java program always start with the classes and objects. That's why we called it a purely object-oriented programming language. But our single program will also contain the class. Each program will start with the classes and object concept. That's why we called it Java is a purely object-oriented programming language. As Java is famous for the platform independent language, where the platform means any hardware or software environment in which program runs is called a platform. Since Java has its own runtime environment, that is called the API, and it is also called a platform. Now, where we use a Java nowadays? We can use the Java in making the desktop applications. We can use a Java, or we can use or design any web application with the help of Java. We can able to design any enterprise application with the help of Java. Any mobile application can be designed with the help of Java. Embedded system, smart cards, robot, and the games, all these applications can be designed with the help of the Java. Basically, we divide our Java applications into the 4 parts. First is the standalone applications. Standalone application means if we want to make the applications desktop applications, like or the window-based applications, like if I want to make any media player, if I want to make any antivirus for any particular desktop, then we will use the standalone applications. For that, we can use the tools like the AWT and the Swings. Similarly, second type of application that can be designed with the help of Java, that is the web applications. Web applications are basically that runs on the server side and created dynamic pages. That is called the web applications. We can able to design these web applications with the help of the tools like the servlets, JSP, and many more technologies. Similarly, third type of applications that we can able to design with the Java, that is enterprise applications, like the banking applications. If we want to design any banking application, we can use it with the help of the Java. For that, you can use the EJP tool. Next comes the mobile applications. If we want to make any mobile app, that can be also designed with the help of Java. And the tool which is used for that is Android. Means any application can be designed with the help of Java. Each application, different tool. For each application, there is always a different tool. If we want to make the standalone application, we use the Swings. This is in our syllabus. This is a part of our syllabus. We are going to design in next lectures like the desktop applications. Your project will be on the desktop applications, or we called it standalone applications. Next, web applications can be also designed, enterprise applications also designed, and mobile applications can be also designed with the help of Java. Now for the history, I'm going to share one video with you. Sorry.
Today, we learn about the history of Java.
Now let's move to the features of Java. There are the various features of Java, like the object-oriented, simple, secured, platform independent, robust, portable, architecture neutral, dynamic, interpreted, high performance, multi-thread, distributed. These are all the features of the Java. Now I am going to discuss each feature in detail. Let's start with the simple. Simple is the feature means that Java is very simple to learn, very easy to learn. The syntax of the Java is similarly as that of the C++. If you know the C++, then you can easily understand the syntax of the Java also. And Java has also removed the very complicated features which are present in the C++, like the explicit pointers, operator overloading. These features are removed from the Java. Java is not dealing with any pointers. Java is not dealing with any operator overloading concepts. Also, as in the C++, when we want to allocate the memory or whenever we want to delete the memory, we use the new and delete operator. But in the Java, it is automatically performed by the compiler. There is no need by the user to allocate the memory or to deallocate the memory. It is automatically done by the automatic garbage collection. So that's why we called it a Java is a very simple, or it is easy to learn. This is the one thing. This is the first feature of the Java. Second, Java is purely object-oriented programming language, as it also deals with the concept of the objects. It also deals with the concept of classes, inheritance, polymorphism, abstraction, encapsulation. As you know, the object is basically one single instance. Like if you are holding the pen in your hand, that is one single object. That is one single instance. That is called the object. And the class means group of objects. Group of objects. That is the class. Inheritance, the process of deriving the new class from the existing one, that is called the inheritance. Polymorphism, many forms. Abstraction, that is hiding the unimportant information which is not required to the user, that is hidden with the concept of abstraction. Encapsulation means binding of the data and function into the single unit, that is encapsulation. These are all the features which are also present in the Java, which are available in the C++, but also present in the Java also. Now, next, this is a main feature from where the Java become famous. Like, this is the platform independent. Platform independent means the Java can run on any platform. Like, we make the class file on the Windows operating system, and that class file can be run on the Mac operating system, that can be run on the Windows, that can be run on the Linux. Basically, Java works on the one concept that is called a write once, run anywhere language. I repeat, Java works on the concept of write once and run anywhere language. That is the main concept from where the Java become famous. That's why it is called the Java platform independent. That is the Java is a platform independent language. Next, Java is very secured language as there is no concept of the pointers. We can easily develop the virus-free systems. We can easily develop the virus-free systems or any software. Now, Java is also a robust. We call this robust in the because there is no concept of the pointers in Java. There is no concept of the pointers. So there is no problem of storing the data. There is no issue of deleting of the memory, deleting the space from the memory. Automatically is performed within the Java. There is a concept of the exception handling. There is a concept of the type checking. That's all these features make the Java robust in nature. Like the concept of exception handling, the concept of the type checking. There is no concept of the pointers, so memory can be easily implement, or we can easily work on the memory. The Java can use the memory in a very strongly way. That's why we called it a robust in nature. Now, next feature that is very important, architectural neutral. Basically in C++, as all of you know, if I am storing the data on 32-bit architecture, if I am storing the data on the 32-bit architecture, then if I take the int, it will occupy the 2 bytes of memory. If I am taking the data type int, it will take the 2 bytes of memory in the case of 32-bit architecture. But same integer data type will take 4 bytes of memory if I am working on the 64-bit of architecture. I repeat, in the case of C programming language and in the C++ programming language, if I'm taking the one data type int and I'm working on the 32-bit architecture, then int will occupy the 2 bytes of memory, as it depends upon because C is the machine dependent language. It will occupy 32-bit architecture. But if I'm working on the 62-bit architecture, then it will occupy the 4 bytes of memory. So data type storage varies from the system architecture. If I'm working on the integer, it will occupy the 32-bit. If I'm working on the 64-bit architecture, it will occupy the 4 bytes. But in the case of Java, there is no such concept. If I say int means it will occupy the 4 bytes of memory. Whether you are working on the 32-bit architecture or whether you are working on the 64-bit architecture, it doesn't matter. This is only due to the platform independent concept. That's why we called it architectural neutral. This is the one most important feature of the Java. The memory in the case of Java is fixed for each data type. It doesn't vary from the system to system. But in the case C++, it varies from the system to system. As portable in language, as we can carry the bytecode to any platform, like here, we have taken there, we can take the class file and can be work on any machine that is a portable in nature. Next, high performance. Yes, Java is faster than traditional interpretation. since bytecode is close to native code. That means bytecode means that is easily or understandable by the machine. Bytecode is easily understandable by the machine. If it is easily understandable machine, that the machine can work with high performance. That's why we called it Java has one feature of the high performance. Distributed nature. We can able to create the distributed applications in Java. Multi-threading, that is very most important or the very famous feature of the Java, that is the multi-threading. Multi-threading means we can able to work congruently or at the same time multiple operations, like we are sharing the screen, I am delivering the lecture, you are viewing the, suppose you are also listening the video. That is multiple things are happening at the same time. This is due to concept of multi-threading. Okay, that is also one main and important concept of the Java. These are all the features which make the Java as a famous language. Now, next, the difference between the C++ and Java. Why Java become most popular than the C++? As all of you know that the C++ is a platform dependent language, that is the architectural neutral. Java is a platform independent language that we have already discussed. Java is mainly used for system programming. Listen carefully. I repeat, Java is mainly used for system programming. Means we use a Java, a C++ concept for designing of the systems, system softwares. Whenever we want to design any system software, we always prefer to use the C language or the C++ language rather than that of the Java. It is best option whenever you want to design any system software. Now system softwares are, that is compiler, assembler, editor, any debugger you want to design. These are all the system softwares that can be designed easily with the help of the C and C++. But if you want to design any application like the antivirus, Adobe Reader, anything you want to design, like any application, then it is good practice to use the Java. Any mobile application, then you use the Java. Java is used for designing of the application. C++ is used for designing of the system softwares. Application software is designed by Java. System softwares are mainly designed by the C++. There is a concept of there is one go-to statement in Java, C++, but in Java there is no such statement. But in Java there is no such statement present in the like a go-to. Now there is a concept of the multiple inheritance in Java, but in C++. In C++, there is a concept of multiple inheritance, but in Java, there is no such concept of the multiple inheritance. In C++, there is a concept of the operator overloading, but in Java, there is no such concept of operator overloading. As I already discussed with you, that Java supports pointers. We use the pointers for storing or allocating the memory, but all the operations performed internally without the interference of the programmer in the Java. There is no use of the pointers in the Java. C++ is uses only the compiler, but Java uses both the compiler and the interpreter. Java works on the both things, compiler and the interpreter. C++ supports call by value concept and a call by reference concept. But Java supports only call by value concept. Why? Because as you know, the call by reference and the call by address, that deals with the pointers. But in Java, there is no such concept of the pointers. So it only deals with the call by value concept. There is no such concept of the call by reference. or the call by address in the case of Java. Structure and unions are present in C++, but doesn't present in the Java. Whenever we want to use any multi-threading concept in C++, we have to use third-party libraries. But in the case of Java, it is inbuilt feature provided for creating of any multi-threading application. These are all the differences and some applicational features of the Java and C++, where we use the C++, where we use the Java. Now, we note one more important note. Two things, that is Java does not support default argument concept. I repeat, Java does not support the default argument concept as that of the C++. In function, we pass the default arguments, but in Java, we can't able to pass the default arguments. Java does not support any header files. Whenever we want to fetch any data, we use the import keyword to fetch any libraries. We use the import keyword rather than that of the header files. We never use the header files in the case of Java. Instead of the header files, we use the import with the name of packages. In this way, we use the Java. Now, how Java works? This part we had already discussed in the lab part also. As you know, source code, that is a Java program, we save it with the extension of the .java. And then afterwards, with the help of the Java C compiler, we compile the program and it will provide us a bytecode. Basically, this bytecode is an assembly language, like the add A, comma B, subtract assembly language. Okay. And this bytecode is transferred to the JVM. And JVM is responsible, which include the Java interpreter, JIT compiler. Java interpreter means it will fetch the code, one line, transfer to the system. Fetch another line, translate, send to for output. Take another, translate, send to another. JIT means just-in-time compiler to speed the execution of the, to speed up the execution. In this way, we use the how Java works. First, we write the code. We give the command Java C, that is the compiler to work, which convert a high-level language into the bytecode. Afterwards, the bytecode is transferred to the JVM. Within the JVM, there is an interpreter and a JIT. JIT is responsible for speed up the execution, and the Java interpreter will convert the code line by line into the machine understandable language, and then it will provide output will be provided to the user. As here it will be the machine understandable language, it will translate that and then provide us the output, and that provide the output. Okay, students.